Hi, ElixirConf. So great to be here. Thanks for the warm welcome. Just enough plug to build a web server. That was a tough title to choose, and we will revisit it a few times during this talk. My name is Ole. I'm from Germany, and just to fulfill the cliche, I like to start on time. I didn't manage. I'm sorry. If you got any feedback during this talk, or I don't know, you want to get in touch, CodeStars, that's how you can find me almost all over the internet, unless this nick was taken. It's complicated. Twitter works. You can also find my blog at codestars.eu, where I don't blog. So my blog turned into a website. This is how blogs usually go, right? Everyone's on Medium now. I'm also running the Hamburg Elixir user group, and we invented the Elixir cocktail. If you haven't seen it, it's pretty much worth a look. It looks pretty cool. It tastes okay. I work for a company called ZSimple. You might have recognized us because we do this awesome stickers, but we're not a sticker company, so we're a DNS company. And we do everything you need to do. We help you doing everything you need to do with DNS, so you can register domains, manage it, and we have a pretty awesome API and also an official Elixir client. Talking about stickers, I also have this sticker. I have it with me. It's our official Elixir one. And I hope this is another additional motivation for you to stay around, because I want to give it away after my talk. So just enough plug to build a web server. What is in there, actually? There's a lot of fill words, obviously. So we have plug, we have web server, and we have the part of building it. And this is also the three topics I want to cover in this talk. Let's start with plug. Imagine you've never heard something about plug, and I'm sure the truth is the opposite, so you probably all heard about it. But if you don't know it, you Google for it, the first thing you hear is the GitHub repo. And the GitHub repo has pretty much on the, you say above the fold, so before you're scrolling, unless you're on a really weird device, you can see the following explanation what plug is. First, it's a specification for composable modules between web applications. And second, a connection adapters for different web servers in the Erlang VM. Which is funny, because if you check the actual implementation, there's just one adapter for Cowboy. But it's the option. It's about having options. And plug really delivers on that. Well, words are words, and if we are in a coding world, code matters. So let's take a look at how the code actually looks like. And that's the interface you all probably are all familiar with. So we have the import plug connection, then we have a function called init, and then we have a function called call. We will revisit this plug a few more times during this talk, but this is just how a plug usually works, and all the web magic happens in this call function. But plug, this alone is not a very powerful tool. There's a key piece missing to this, which I like to call the plug of plugs. And the plug of plugs is basically a way that plug gives you to combine multiple plugs into a single one. And that way you can compose really huge apps. So let's take a look at how this would look like. So plug ships with a plug builder, that gives you a macro, the plug macro, where you can put together different plugs. And every plug is sticking to the Unix philosophy of doing only one thing, we're doing it really well. You can also override the init function and the call function, but this is already optional, so just the upper part would be enough. And I'm pretty sure you have seen this behavior before. Can you recall where? You use it probably every day if you're working with this framework. So in Phoenix, when you use the Phoenix router, this is basically what the Phoenix router is. The Phoenix router is a plug. It is a rather complex plug. It offers a lot of flexible option of putting it together. But in the end, this thing, and this is just the default generated scaffolded router, stripped down to fit on the slides, this is a plug. It just hides a lot of the calls. But here you can see that you're plugging together, and this is where the name comes from. You can plug together different aspects of your app and different behaviors of the app. So under the hood, Phoenix is just a router. It's a big router and does a lot of other things as well, but that is still the router. Well, that was the plug part of the talk. Now let's take a look at web servers. And first, let's address the elephant in the room. Who, with a brain in their head, would ever come to the idea to write a web server? Apparently, I did, or at least I had the idea to do it. And I found myself, like, in the process of doing it, that it was a really stupid idea. So, in preparation for this talk, I came up with the idea to create this thing, which is called Stupefy, which is the most simplest version to create a web server. And this is also what we are going to see in this talk now. So I want to work with you through this thing and how it was created. And also what code is in there to actually make it work. And a little bit of a disclaimer here, this thing is really stupid. All the code is kind of shit, there are no patterns in there, and everything you should, like everything you see here, you should not do in your actual Elixir app. So it's like a counter example. There's almost no OTP in it, and talking about OTP in Erlang, you have all heard about let it crash. This web server just crashes, so it's just it doesn't get restarted or something. It's also not threaded or something, so it can serve a single request at a time. And when there's a second one coming in, this has just to wait. But still, and I think this is what's cool about this, it's very simple, and that is why it's stupid, and also easy to follow. And we will see this in a few slides. So let's take a look at the HTTP protocol. Probably you might know this, but I want to just cover it really quickly so we are all on the same page. We're taking a look at HTTP 1.1. This is totally different for HTTP 2. I gave a talk at ElixirConf in Orlando last year. If you want to know more about HTTP 2, you should definitely check this out. But for the simplicity of this talk, we just stick to this protocol. It is a text-based protocol. This is what makes it so easy. And now let's dissect it and let's see what is actually in there. So it all starts with the request line. So that's the first line of the protocol. It has the HTTP verb, it has the path over here, and it also has the protocol version. Then you have request headers. Headers are usually key value pairs separated by the colon. And then it's a functional programming language, so we have a maybe body. No? Okay. I thought it was funny when I was writing it. And then in the next, so then there's an empty line in the text-based protocol, and then the next line you see is the response from the server, and it always starts with the status line, which consists of the HTTP version, then the status code, and the reason phrase. And if you want to discuss if the reason phrase makes actually sense to have it in text format, I'm all into this discussion because I think this number is totally enough. Then we have response headers. Headers, same thing, key value pairs. What I think is pretty interesting on headers, there are a lot of caveats in there. Almost each header has its own kind of data format, and you really need to know the header key in order to pass the value. Like date, it is obviously a string, but if you want to represent it in an actual data format, it could be an Elixir date. Also content type is basically a list separated by a semicolon, while cache control, even though not in this example, is also a list, but separated by space. So HTTP headers are really a horrible thing to deal with. But it's just because it is like that because it evolved over such a long time. And then there's also almost always maybe a response body. So let me show you how to build a web server with these five simple steps. And now we come to the meat on what the building actually looks like. In order to do so, you start with listen. Then you come to accept, parse, then you delegate, and then you respond. This is the 5 steps you need. And now I want to walk through all these 5 steps and also walk through the code. And let's do it all together to see what's needed to make plug work. Let's start with listen. So here's some Elixir code. This looks almost like an OTP app. It has the same interface. It does not have all the upsides. But I wanted, when I just do IEX, -s mix. I wanted to start automatically. This is why it has the interface of an OTP app. First thing we do is we open a TCP socket on a specific port. The port is magically appearing in here. And the options I'm passing here is binary to receive data as actual binaries instead of character lists. Then we have packet line that tells GenTCP to return data line by line rather than packet by packet. And also active false tells GenTCP to block on GenTCP receive until data is available. And then we log the line that the server is now running. Here you see the only concurrently thing I needed to put in here because this is an OTP application and OTP applications need to return immediately. So I got the control flow in this task in order to step out here and then return OK and the PID of this thing. So here you see that's the interesting code part in here, right? So this brings us to the next step of building this thing, which is the accept step. So it's a loop. That's also what the function suggests. It gets the socket and a plug. And what we're also doing here is we are accepting a connection. This gives us a single TCP and a single active TCP connection. And then we pass this connection down to a serve function. And then the serve function returns a stupefy request. This thing is aliased here at the top. And builds up the request and returns the request. And then the request will be passed down to respond. And respond also takes the plug and the actual client. Respond is responsible for doing the actual TCP sending. And thus, after respond is done, we can just close the client and then continue to the acceptor. And there you see it's just sequential. The second client needs to wait. This is a rather crucial part of the web server here. And I want to take a look at this struct. It's really simple. It has the 3 keys. The one is the awaiting, which is kind of it's a state machine. And it tells the request what should be next. And you'll see in a second how I'm going to use that. Then we have a list of headers. A header is a tuple of 2 strings, basically. And then we have the status line, which is just a status line. So with this request, you can see that I'm not even considering dealing with bodies. So there is no request body in this simple example. So let's take a look at the serve function. The serve function is responsible to build up the request. And here you see how the state machine is kind of functioning because I'm pattern matching on the awaiting key. And if I'm awaiting a response, I'm terminating the serve function. So the serve function is a recursive function. Here's the actual implementation. So you get, again, the socket and the request object. First thing you do, you pipe the socket into read line. That's a very thin wrapper around GenTCP receive. So you get a line back. You pass that line and fill it into the request and update the request. So we pipe the actual line to parse. Parse gets line and request, and then we update the request. And then we loop through serve. Let's take a look at this step now, because that's the next step in building a web server. That's the parse step. How does parse look like? Again, it's recursive, or it's a multi-function, multi-header function. And again, when we're awaiting the status line, and that's the first thing. That's the value it is initialized with. Because this is what you see the first in a request, right? So it should start with that. And when we see the status line, or when we get data and we're awaiting a status line, we know that the data is the status line, so we update it, and then we know that we're awaiting headers. We know that we're awaiting headers because regarding to the RFC, every request needs to have at least the host header, so we know that there's at least the host header, unless it's not a valid request, and then it's okay to blow up. This is, again, a termination function, so when we're awaiting headers, and there is none anymore, so that's the empty line between the request headers and the request. Then we just said that we're awaiting the response now, because, again, we don't deal with request bodies here. Otherwise, we would set this to body now and then parse body if there's a body or not, so this would just complicate it more. And then we have the case where there are actual headers coming in. So we're awaiting headers, there's data, this doesn't match. So we know this is a key value pair, and then we pass the header out, append it to the headers, and then we're awaiting more headers. because this could match. If that was the last header, this one will match. Now we come to the interesting part. Now we want to connect it to plug. And how does all that work? This brings us to the delegate. Let's take a look at the respond function. So remember, respond gets the request, so that's a Supify request. Then we pass in a plug, and I want to talk about this in a second, why it is a tuple, and then we also receive the socket. That's the code of respond. And here we really see how plug gets in here, and here we come to how plug interact with all of that. First thing we do is we build up the connection. And the connection is a crucial part of plug, and I want to show this in a minute. And this is a plug struct. It's called FlatCon. And this one is passed to plug, to the plug we get passed. And we don't only pass the plug, but we pass down a tuple. So we pass down a tuple because we need to initialize every plug. Remember, there was the plug init, and we did this right at the beginning. So you only do the init once. And the init, whatever the init returns is the options the plug will receive when you call on it. So this plug variable here is a module. It's an Elixir module. And due to the fact that we know it's a plug, we know it supports the call function, and then we pass down the connection that gets built up here and also pass the options. This is basically where all the magic happens, but it's just 2 lines, so I want to dig deeper into both of these calls in a second. Let's take a look at the plug connection now. So the plug connection is a simple struct with a massive 140 lines of documentation and around 30 fields as a struct, and then it has a few supportive methods. It's really interesting. So if you want to read any source file in plug, I really recommend to take a look at FlatCon because it has all the greatness in there. Also, you see how to write extensive Elixir docs. It's pretty great. So let's take a look at this struct. Again, FlatCon is a struct. It's a module and has a struct in it. And this consists of a variety of different fields. And in order to make sense of all the fields, in the documentation, these fields are grouped. So I also want to introduce them in a group manner. So it has the request fields, the fetchable fields, and the response fields. Starting with the request fields, we have the host, which is passed out of the host header, which is usually www.example.com. Then we have the HTTP method, so get, post, options, head. We have the request path, and there you could, the issue with the request path is that it's usually a list. Oh no, that's not right. The request path is not a list, that's a string, but then there's path info, which is a parsed segment. Then we have the port. We have peer and remote IP. That's a pretty interesting combination. So peer is the actual TCP peer the server is connected to, and remote IP is meant for other plug middlewares that understand the x-forwarded4 headers to populate this field. So this is what you're connected to, and in modern application setups, this is usually a load balancer because your load balancer dispatches the TCP connection, and then the remote IP is get populated in a later step with whatever whatever the customer wants you to think the remote IP is, because getting an actual client IP is almost there is no guarantee that you can get it. So be aware of that. Then we have the request headers, which is a list of tuples. We have the scheme with HTTP or HTTPS in 99.9% of the cases. Then we have the query string and a few other fields. Like I mentioned, path info and script name, but I don't want to dig deep into them here. We have the fetchable fields, and I think fetchable fields are pretty interesting because they are only populated when the plug middleware requests them. So you don't have this field set unless you fetch cookies or you fetch body params. You have query params, you have path params, and then you have params, which is all of these 3 combined in here. So you really need to call fetch cookies or fetch params in order to these fields to be populated. If you don't call this before you get an FlatCon unfetched struct, And yeah, that's used to, this is used for pattern matching, so that you can pattern match on the struct. That's pretty handy as well. Then there's also request cookies. And the difference in here is that the request cookies are not modified, while the cookies can contain request and response cookies. Then we have the response fields, obviously starting with the response body, the response character set, the cookies, and the headers. So these are only the cookies you wanna set, right, in the response. And then we also have the status code. And this is pretty interesting. We only pass an integer, so the reasoning phase is not part of the struct and will be constructed later on, and we will see this in a second as well. There are also 2 more categories, but they're not part of like what every user of Plug should know, because they're kind of only for implementers or people that deal with the actual library or writing their own plugs. And the private fields are the adapter and then a field called private. Private is really meant as a shared library data as a map, and then the adapter, and this is also what we saw already, is a tuple. So it's on the first thing, it's a module, and then the other part of the tuple, so the index 1 element of the tuple, is what they call a payload, and we will see like how this works in a second as well. Then we have the connection fields. The connection field has a signs, which you probably all have used because this is shared user data as a map. So if you want to transmit any data from one plug to the other, you would set it at the assigns field. Then we have an owner, which is the process ID of the process that owns the connection. In the case of Stupefy, it's really easy. It's the task, the only thing that's running. It is used because Plug sends messages to this process along the way of parsing and dealing with the request. Then we have halted, that's a Boolean flag in order to know if the pipeline was halted. Then there's secret keybase, you probably dealt with that if you want to get your test pass, because you need to set this from the outside. This is not populated automatically because no one should know the secret. That's what secret means, right? No one should know that. And then we have the state as well. And the state is the state of the connection. So it starts with unset because the response body is not set, then gets to set, and then to send or chunked, depending on the response model. So let's jump back into code, and then let's take a look at the build connection. Because this is really where we make this, where we bring together our Stupefy server and the plug connection. First thing we do is we pass the status line. It's just separated by white space, so we just split on white space. And we get the verb, the path, and the version. Then we transform the headers into a map in order to access them more easily. This is kind of a dangerous thing. Again, don't do this because headers can occur multiple times, and that's okay in HTTP. We would lose this here. And then we're building up the minimum set of fields we need in order to make this connection working. So we have the host, we set the method, we set the request path, we set the request headers, we also set the scheme, and then the adapter and the owner. And I really want you to take a closer look to this line, because what we're doing here is we're setting the adapter, and this is also the thing you saw before. And the adapter is not only the module, but also what is called payload and plug. And this is in order to identify the actual connection. So you need a way to reference back to what connection should the response to be sent to, because you're passing away the module, and due to the fact that there's no state, you need to pass along the state. And this is basically passing along the state of the web server. In my case, it's a socket, so it's an Erlang port struct or a port data type. I think in Cowboy it's a struct. You can basically use any term, so you could also pass along pits, integers, whatever is necessary for your case. We'll see this in a second again. So let's take a look at the response function. So now we've built up the plug connection. So now we have an actual plug connection, and we're passing the plug connection into the plug call. So plug, again, is the module, and we know due to the fact that it's a plug compatible module, we know that we can call the function call on it with the connection we just built up and the options we initialized at the beginning. Now let's take a look at the plug again. This is what we're just calling. So we pass in the plug connection and we have the options. So that line is pretty important. So we import all functions that are defined in FlatCon in order to make our plug work, because we are calling this function over here. What I also want to point out here is the options you receive here is when you use the plug builder, what you pass in as arguments. You can transform them if you want in this step. And whatever you return here is exactly what you will receive here. So you could modify it here or initialize it in any way, so stuff you only need to run once. You could even start like complete supervisors if you want to do that. And then return the PID, and then you would get the PID again passed down here. So that's really flexible. And then what we do here, we pass the connection to the function put response content type, which is text plain, and then we pass down. So that's also a contract of plug. You always return an updated connection struct. So you just pass around the connection struct, and everything you need in plug is in this connection struct. So you pass around this plug connection. This will return an updated plug connection with the correct header set, and then this will also set the state to set, because we set the response body. It sets the status code and also the body. So I want to take a look into what is happening here, because this is a plug function. This is not something our web server does, but still it kind of needs to interact with our web server, right? Because this does not send it yet. So that's the actual plug implementation. I want to give you a second to grasp it. So here you see the method, the function send response. We pass in the connection adapter. Again, we match on the state, because in the real implementation there are multiple function headers matching other states and like doing appropriate error handling. And then we also again pass out the adapter. And here's the thing again, right? So you have this tuple which consists of the adapter, which is the module of your web server, and then whatever you need to identify your web server or the connection on your web server. So in our case, this payload would be the Erlang port, the socket. Then we also have the owner. This is parsed out of the connection here, because in the real implementation it has more code than what I'm showing here. It's also sending a message to the owner that this thing was sent. But this is an interesting line. So on the module we pass in, we call send response with the payload in order to identify it. So in our case, this is the socket. We pass down the status, the response headers, and the response body. Next thing we do is we take a look at this function, because my adapter, which is the Stupefy web server, needs to implement this. So now we are coming to the respond phase. Even though in the plug world we are responding already, this is now where it gets passed down to our web server. So that is the send response in Stupefy. This is the payload again. So you've seen that we pass it all back to plug in the adapter tuple, and then we now get it back in order to identify where we should send like the actual body. Like that is the socket where we need to send the content to. Because again, it's all stateless and the web server doesn't store anything. First thing we do is we ask the plug status util to give us the reason phrase for the status. It's important to do that if you ever find yourself implementing a web server, because in plug you can set your own response reasoning phrases. So you could, for example, override 200 to not be okay, but rather, I don't know, I did it, whatsoever. You can also define your own ones, define your own integers and the reasoning phrases, and this line supports that. And then the next thing we do is already writing back to the socket. Again, read line is like a really thin wrapper around gen_tcp send. It gets the string that you want to send and the socket, and we send the hard-coded protocol. Again, it's just the very simplest version. Then the status and the reasoning phrase. That's the first line. That's the status line. Then we send headers, and this is again a recursive function because there could be multiple headers. That calls like this thing called send headers on its own again, and send each header. So it pops it from the stack and sends it again. I'm not going deeper into that function. Then we are writing another line. This is an empty line because there needs to be an empty line between the response headers and the response body. And then we are writing the body line. That's it. This is the whole response send. Then regarding to the plug protocol, we need to return a tuple. The first thing is OK or error, depending on if it was successful or not. In our case, obviously, it's always successful or it blows up. This is body send. But in actual implementation, this is recommended to be set to nil because it should not give you the impression that you're still able to modify it because it's just not there anymore because you send it over the wire. This is used in tests in order to assert. We'll see this in a second again. And also, we return an updated payload because imagine this would not be just a port, but this could be a struct or a PID or it could be whatsoever. So this line needs a mechanism to update the payload and return it back to plug. So plug supports a concept called adapters, and this is really what you think it is. It's an adapter to support different web servers. If you check out the source code on GitHub, there's the Cowboy adapter, and this is what you use probably every day when you start your Phoenix app. That's basically the default go-to adapter because it's there for a longer time. It's pretty hardened and also pretty stable. And this is the behavior you need to implement. So we just saw the send response, and you would also need to have implemented the other callbacks here. And I want to get over all the callbacks now really quick. So the first function you need to implement is send response. You get the payload, the status, headers, and the body. And then you're meant to return the tuple OK with the send body. Again, this is only meant for test cases. So you can test your plug and then assert on the body that was sent. In real implementations, you better send back nil because it should not give you like an idea or a false sense that you could still modify it because it's gone. And then again, the payload, an updated payload. Then we have send file, which is for sending files. You get the payload, the connection status, the headers, then the file is a binary offset and length, or you can just send everything at once. It returns OK, then the send body, so basically the signature is similar to that thing. Then we have send chunks. You get the payload, the status, and the headers. And you have then an actual chunk, which gets the payload and the status. Then you have a function to read the request body. This is one of the fetchable fields, though that's not there that's not always there. You really need to fetch it. And also it improves like the performance because maybe there's a request like a head request where you don't need the request body, and then you would not waste time to reading it from the wire or wasting time in parsing it. It has a more complicated way of returning, or multiple ways of returning. And then you also have parse request multipart. HTTP multipart is basically how they made multiple file uploads work in HTTP. I think it's real bullshit. But it's really complicated. It's just a really complicated thing. And this is how plug supports that thing. And if you want to write your own web server for plug, this is basically all you need. This is just six functions and construct the plug. And when I was like doing the research for this talk, I was pretty much blown away that it is really that easy. And this is all you need. And in the example of Stupefy, the only thing I needed was that. So that single function and the plug I showed you before, that is everything you need to make it work. So during all of this, I really realized that you can learn a lot from plug. And I was thinking about why it is that way, and I came to the conclusion that plug is one of the first things was one of the first things that exist in Elixir, and also almost all the core members of Elixir contributed to it. And if you want to see a library that is really written in a way that core members would write a library, plug is probably one of the ones you would take a look at, right? Other than Acto and Hex and this kind of stuff. This is one of the core things. And I thought while reading it that it's pretty cool to learn from them and to get a grasp on how I should write Elixir. And I was trying to extract a few patterns or a few things that stood out to me while reading the source, and I want to share this with you now. And the first thing that stood out was the idea to pass around modules. So passing around the tuple of the model of the module and the payload to identify your request. That was totally new to me. I was not aware of this concept in Elixir, and I think this is so great. So this gives you so many options and so many possibilities in your own code if you're writing a bigger application to pass around an actual reference and be the reference like exchangeable. That was a pretty cool thing. And also structs over gen servers. And Jose was pointing that out in his keynote yesterday as well. And also Sasha wrote this blog article about spawn or not to spawn, where he talked about process boundaries and functional modeling. And this was also what I was realizing when I saw this real plug, this connection struct. It's a struct that consists of 40 fields and has like this 140 lines of documentation. And this is really, this really stood out to me because I always thought in Elixir it's the way to go is spawning a gen server and then passing around PID. But this is not how it's supposed to be, as Sasha wrote in this blog post, that processes, and also Jose said, processes are not a language design tool, it's a concurrency design tool. And this was another thing I really realized. And having a plug, having a struct with 40 fields is not a bad thing, right? You should not feel, you should not think that's a code smell. It's a good thing if it makes sense. And then the other one is the really, really simple API. So think of the API of a plug. It's basically two functions. It's init and call. And with these two functions, you can have a thing like Phoenix. So that's super powerful. Also implementing your own web server with just 6 functions, that was really a mind-blowing moment for me. And I think when I'm writing software now, I really think about the API that I'm exposing, and I try not to make it super bloated and support every use case and adding methods over methods, maybe even with different hierarchies, and making my documentation more complex. So now, looking at all of you, I know you have one question still open. Does it actually work? And I really, like, if the demo gods are with me, I want to try to demo it, and that is definitely not big enough. So can you read that now? I think that's good. So let's start the Stupefy server. And now it's running on port 4400. And then we have this one here. So just make this bigger, so just trust me, it's there. And then I do a curl request, do the same thing. And you see, we have everything we need here. So curl is firing, and then Stupefy is actually passing this to plug, and then plug returns hello world. With this just, you really, and I'm not kidding here, you saw all the lines of the Stupefy web server. There was nothing I was hiding. This is also why you see the struct in there. That is it. This is all you need to implement a web server, and this was pretty cool, I think. Now let's get back to my slides. So yes, it does actually work. This gets us back to the last second here. I have stickers up here, so when I'm done with the talk, I invite you all to come up here, talk to me about Plug, talk to me about ZSimple. If you want to try out our service, you can have 1 month for free using that URL. And that's all I got. Thank you very much.